Today we're going to talk about naming ionic compounds. Now with today we're going to go from the name to a formula. Now let's first discuss though what we're going to do with an ionic compound and what an ionic compound is. Ionic compounds are compounds that are made up of ions. I know, crazy name, putting them both together, compound words, they're tough. So what we have here is we have the ions, which are our metals and our nonmetals. They're going to come together. I know, cats and dogs living together, the world is going to come to an end with these things happening. Our metals. When we did our metals, we talked about the metals. Metals formed positive charges. Okay, so if metals are positive, we give them a particular name. They're called cations. I know it looks like cation, but that is a cat. Big gap right there. Ion. Okay. Here's how I remember it. I am positive that Miss Estes does not like cats. So we've got a cation. The anions. Okay. Not to be confused with anions. Anions are negative. Positive up there. So those are the things we're going to be dealing with. The anions are our nonmetals. They're going to be on the right side of the periodic table. So we're going to be putting the positives and the negatives together and hopefully ending up with no charge. Alright, so what we're first going to want to do is we're going to want to write our metal. So my first rule is metal goes first. That's a tough rule. So whenever I have the one that is closest to the left side of the periodic table, that's always going to be written first. Now, so I can balance charges later on, I'm going to always make sure I write it with charge. Now in class we discussed this as being the oxidation number. Okay, we'll talk about the oxidation number a little bit more, but the oxidation number, remember the columns that we were working with? The columns tell us what charge it is. Now there's going to be some that are a little bit more difficult that we need to know a little bit more about once we get to the transition elements. But your periodic table is going to help you out a lot with that. So I write that with the charge. The second thing I want to do is if it's one of those transition elements, again we don't know what it is, but if it's a transition, we write with Roman numerals. Now, I had students that always come up to me and say, Mr. Brewer, I don't know my Roman numerals. Now, we need to know our Roman numerals at least up to the number 7. Or for those of you that know Roman numerals, VII. If you know that, you understand it. Aspens are the way they are. So our Roman numerals, we should know I is 1, II is 2, III is 3, IV for V is 5, VI 6, and VII 7. So we need to make sure we at least know up to the 7. Okay, so this will take care of our metals. Again, I'm not explaining this right now. You just want it in your rules because you want to use this on quizzes and stuff like that. Okay, the next thing we want to do, we want to write our nonmetal. So we write our nonmetal second. Now, I also want to do this with charge. Now, if the metals were written with the charge, their charge should be positive. So the charge down here should be negative. It's going to offset that. Now, you're going to be responsible for what's called a polyatomic ion. Okay, polyatomics, poly means many, atom is the small little pieces that we've been dealing with. So it's many atoms. Things like hydroxide. Hydroxide represented as OH negative. It has an oxygen, it has a hydrogen. It's got a negative charge though. They come together. So if it looks like you have a bunch of letters together and they're all capitals, odds are you've got a polyatomic ion in there. Okay, so if I have a polyatomic, that's my next rule. If polyatomic has more than one use parentheses. Okay, and the reason I would use parentheses is if I had something like, write it over here, you got this, Zach. If I had hydroxide, which is OH, I want to keep it as OH, so it's hydroxide still, but I want to represent having two of the whole thing. So it would look like this. Okay. If I didn't do this, it would look like I have one O and two H's. That is really, really bad. Alright, the last thing I want to do is I want to balance charges. And we are going to show you how to do that just in a second. Okay, so make sure we get a good shot of those. Get all of them so you can take them down in your notes. Make them look beautiful. Alright kids, we need to put an ionic compound from a name into a formula. Pretty tough stuff. So I'm going to go and I'm just going to use my vast knowledge of the periodic table. And I'm going to write a compound. We all right, Zach? Folks at home, there's a tiny earthquake in here. I think we're okay though. Okay, so my vast knowledge, I'm going to write a compound of lithium. And I am going to start off really slow. And I'm going to go fluoride. Whoops. Have to get that L in there. That's not an H, that is an L. F-L-U-O-R-I-D-E. Fluoride. Okay, so when I do something like lithium fluoride, I'm going to go by my rules and I'm going to go step by step. Sometimes the rules won't apply, but I'm still going to go through them. So until you really get the hang of it, stick with your rules. So my first rule, metal goes first. Which one of these is my metal? I'm going to go with the one that is further to the left, lithium. So I'm going to write the atomic symbol for lithium, which is Li. Now, it says to write it with the charge. If I go to the lithium on the periodic table, I see it is in the first column. That first column tells me that it has one valence shell electron. That valence electron is going to be lost, making me have a positive charge. So it's Li positive. Alright, if it's a transition metal, that's the next rule. It's not a transition metal. I can skip this one, but I still looked at it. My next rule, non-metal goes second with the charge. So my next thing is fluoride. Now wait a second, fluoride is not on the periodic table. What is on the periodic table is fluorine. Okay, what happens when we're naming things, and we'll see that on the other video when we name, is we drop the ending and change it to IDE. So, this is really fluorine, it's just the ion version. So it is F, and it is one away from being a cool kid. It is one away from being like neon. So it wants to gain an electron. So if I were to write its charge, it would be negative. So I have a 1 positive, I have a 1 negative. There's several ways I can do this. I'm going to show you several different ways to do it. So, what I like to think of is I have 1 over here, 1 positive, and I have 1 negative. Overall, what happens to them? Okay. 1 and 1 balance out, right? 1 positive, 1 negative. So they offset. So when I'm down here at my balancing charge step, to me, the charges just are balanced. So I'd write LiF. That's one way of doing it. Another way of doing it is the cross method. This works a lot better when you have varying numbers. Let's say you have a 3 here and a 2 over here. But what I do here is I pull them down to the opposite side. This is a 1, this is a 1. So I'm left with Li1, the 1 is implied because I wrote it out, and F1. Once again, the 1 is implied because I took the time to write the F. So that's my cross method. That's going to come in more handy once I do some more and we do some work on them in class. The third version is actually using my manipulatives. Now, I'm going to use a manipulative that has the same charge, even though it's a different element. Lithium has a 1 positive charge, so I'm going to bring over potassium. Potassium has a 1 positive charge as well. He's kind of in the same family. That is why they're in the same family, is they have a 1 positive charge. Okay, chlorine, who's in the same family as fluorine, when I make the ion, that's chloride. It has a 1 negative charge. Same family, they're a halogen. Okay. These manipulatives, they're kind of handy. They're going to be available to you. I can plug them straight together, and if I end up with a shape that's not all jaggedy and weird, ta-da, I've made it. Okay, KCl, or in our case, it'd be LiF. All right, now next week, we are going to be working hard on naming formulas. We're going to be working hard on going from formulas to names and names back to formulas. It's going to be a pretty busy week. It's going to be pretty hectic. We're going to be doing a ton of stuff. Chemistry, not the applied chemistry. Sorry guys, I don't want to leave you out, but this is just specific to chemistry. Chemistry people, you need to learn your polyatomics. You'll have a list of 25 polyatomics. You'll have to memorize all those with charge. It's lots of fun. So I'll have you a list for those for the week. You'll have a quiz over those next week. All right. So we have naming next week. We're going to finish up a few things on the periodic table and hopefully get started.